Welcome to Skills Lesson 1. In Skills lessons, we look in more detail at some of the things that we need to do in R, more detail than we look at them in the problem studies. This Skills lesson is about what we do before we even start working in R, what we can do to make our life in R easier. In particular, how we can prepare data so that it's very easy to import into R and work with in R. And as in many activities, preparation really does help build a foundation for much easier work later on. So, preparing the data. Of course, this first starts with the question we're interested in, and a hypothesis and an expectation. That question leads us to do some research, and doing that research creates some data. We go and get that data, and then we need to put it into the computer, and hopefully do that in a way that makes it easy to work with that data in R. So the aim of this skills lesson is to look at how we prepare data in such a way that it's very easy to import into R and then easy to work with in R. We're going to use an example of an experiment where we were interested in the effect of temperature on perspiration rate of people. So we've looked at a bunch of people and measured how much they perspire when they're in different temperature environments. In preparation for doing that, let's say we create an Excel file that we're going to use to record the information on. So let's open Excel, just like we would do for real, and we're going to put in the column names of the variables that we will record. So the first one could be the date that we make the observation on, the second, the time that we make that observation, the person or subject upon which we make the observation, their age, their sex, the temperature at which we make that observation, and the measured rate, perspiration rate. And then we'll have a final column here for any notes that we might wish to make. Now the purpose of writing this Excel file, this data sheet, is that we're going to print it out and actually use this to record the information on. And when we print out an Excel sheet, it might not show these grid lines, so it's going to make those grid lines explicit, all borders. So now we've got some grid lines. We'll format, then we can select the area that we want to print. We go to File, Print, and maybe we'll turn this to be a landscape. There we go, and just scale it to fit the page. Cool, and then we could print this out and we'd have something that looks like, I'm not going to actually print this one, something that looks like this. You can see that. A data sheet that we're going to take into wherever we go to record the information, and we'll fill this in by pen as we go along. And we'll end up, after we've done the study, with something that looks like this. That data sheet. And you'll notice that I've got entries in every cell of this data sheet. There's no blanks. Blanks would be bad because it could be a bit ambiguous about what's caused those blanks. Maybe the person decided they didn't want to be involved and we didn't actually get a measure of respiration rate. Or perhaps we just forgot and we don't actually know what the cause of those blanks are. So once we've got a data sheet like this, kind of at the end of the day or at the end of the session, we should make sure that all of the cells are filled in, or there's some kind of comment in there that tells us why there's not a cell filled in. You can note just here that I've used kind of speech marks to be dittos, because all of these were done on the same date. So it's fine to do stuff like that. Good, so there's our data sheet. And now we go back to Excel. And because we've formatted this in such a way originally, this is exactly how we're going to type the data into Excel and have it in R. And that arrangement is such that each person or each thing that is being observed is in a separate row. So each observation is in a row, and then variables are in columns. So in a second I'm going to describe, or in a minute I'm going to describe a different way to format it that's not quite as ideal. But for now, we've got exactly the kind of formatting that we want to type it in. I'm going to close this, or just minimize this, and open the file in which I've already typed in that data. Here we go. So here's that data. You'll note I've replaced those dittos with the actual data here. And there we go. That's pretty straightforward, right? The next thing I would do if I was doing this for real is to print this Excel datasheet and then sit down with this printed version next to the handwritten version that I originally collected and check that those two match up exactly. That's really important. Every time I've ever done this for real, I've made mistakes during data entry, made mistakes with my fingers typing into the keyboard. So it's really important to go and do that double checking to kind of verify that we've entered the data correctly, because once the data is in, it's really our foundation. If the data is not quite correct, everything else is going to be not quite correct. So it's really important to get this data set really solid. Okay, so that's the data into Excel and checked. Now, R really doesn't particularly like reading in or importing Excel files. So we are going to save this as a file type, or type of file that R does like importing. That particular file type is called a comma-separated value file. I'm going to tell you why it's called comma-separated values in a second. First, let's save it as that file type. So we go File, Save As, and then here in the Format drop-down menu, we can go down and see Common Formats. Oh, comma-separated values, brilliant. Let's select that. I'm going to save it to the desktop. Keep that file name, data entered, the temp rate. Press Save. Now Excel doesn't really like saving these CSV files, comma-separated value files, so it asks us a bunch of questions. Do you really want to do that? You're going to lose some information. You'll lose formulas or graphs, but we haven't got any of those, so it doesn't matter. So we just say Continue, and then we're going to close this. And again, our Excel asks us if we want to save it, and we're like, well, we've already saved it. Why are you asking us to save it again? And it's because it doesn't like saving these files particularly. It's giving us a hard time for not saving them as Excel files. So we just press Save anyway. And then it asks us that same question again. So we press Continue again, and there it closes down. Brilliant. Here's the file on the desktop. This is the blank one I originally created. Good. So that's the data entered. Let's just have a quick look at this file. It's a text file, so we can open it in just a plain text editor. For example, Emacs is a plain text editor. And here it is. This is what it looks like. See, I'm just looking over. Here we go. So this is a comma-separated value file because in each of the rows, the entries are separated by a comma. That's it. Comma-separated values. You can also find tab-separated value files or tab delimited. Delimited is the same as separated, so you can have comma separated file would be the same as comma delimited file. So you can have tab delimited. Sometimes you'll see semicolons here. That's the dot with the comma below. Some people's computers are set up so that when you save it in Excel, it saves it as you save a CSV file in Excel, it saves as semicolon. But I'm going to talk about that a bit later, about how to escape from that problem. Good. So that file is now ready to import into R. We've got it formatted in a nice way, observations in the rows, variables in columns, and it's saved as a comma-separated value file, and we've double checked it so we know it's totally solid. So now we're ready to go into R. Actually, what we're going to do next is talk about other sources of data and how you might deal with getting those into R. But before that, let's just take a break.